Hey everybody, welcome. It's Christina. So I'm going to do a little overview of chapter 5 here for you. And I'll do some sample problems towards the end of this video. And next week, the videos will look a little bit different. I've ordered an overhead camera, so that will allow me to video from above as I'm writing down the problems for you all so you can see those worked out as examples. Just a quick reminder, I do have office hours during the week. So typically those I'll be hanging out here on Zoom, and those are typically going to be Mondays from 11:45 until 3, and then again on Wednesday from 11 o'clock until 11:50, and then also on Wednesday from 2 o'clock to 3 o'clock. Now, if those times really don't work for you, if you're working, you've got to pick up kids during that time, just you're welcome to use my you can book me link, which I'll put in an announcement, and you can book a time that works for you. All right, folks, let's get started. So, chapter 5 is all about solving equations for the unknown. And I'm going to scroll just a little bit. This is, if you're in the physical book, we're on page 122. If you're in the online ebook, we're on page 54. So that is a little bit of a different numbering for the physical versus the online book. All right, so I'm going to scroll down just a bit. We're going to talk about the basic equation solving procedures. Now, if you're like me, you don't remember what you did in high school math, and that's okay. We're going to talk through it today, and hopefully it'll kind of refresh or remind you of some of those things that you learned in the past. And if not, that's okay. What I always tell people is the more you repeat things in business math, the easier it becomes for you to kind of sink it into your brain. So, the first thing we want to talk about is what is an equation? It's essentially just a mathematical statement of equality. So you'll have some things on one side of the equals sign, and you'll have some things on the other side. And the book gives a good example here of 6 plus 4 is 10. So we can all pretty pretty safely say, okay, yeah, I know that, Christina. I know 6 plus 4 is 10. And where we sometimes it gets a little stressful is when we start throwing in the numbers. And those are called variables. We'll learn all about that. And in this class, we have a couple of rules we'll be working with, and those are listed here on your book. So if no number is in front of a letter, you can assume it's a 1. So, like if you see just a B, that means 1B. If you see just a C, that means 1C. And the second rule there is if there's no sign in front of a letter, so like positive or negative. So if you see no sign, you can make an assumption, a safe assumption, that the sign is positive. And positive and negative numbers will come into play as we're going through some of our problems. All right, let's move. We're going to move down our page just a little bit. So they give us an example here to look at. And in solving equations, the really good thing is the meaning of the plus, the minus, the multiplication, and the division. That doesn't change. The x still means multiply. The divide sign still means divide. And there's just different ways that you can write these, and that's listed on your page there for you. So let's take a look at this problem here. So it says, assume Dick Hirsch, an employee of Nike, is 50 years old. Let, let's assign Dick Hirsch's changing age to the symbol A. The symbol A is what we call a variable. So that is the thing that's going to change. So we're calling Dick's changing age an A. So Dick's age 8 years ago is his age minus 8. So 8 years ago it's age today minus 8. And his age 8 years from today in the future, well, we're going to add an 8 to his age. And then if we say somebody is 4 times Dick's age, we're going to say 4a. And that's the same thing as saying 4 times his age. So, like if his age were 20, oh, well, it already told us his age is 50. So, if his age is 50, then in this equation, it would be 4 times 50. That would be what that number would be. And then if we say it's 1/5 of Dick's age, how we get to that is, 1/5 is the 1/5, and we're multiplying that by A. And if this is like, whoa, I don't remember that, Christina, it's okay. we're going to work it together. We're going to work it out with each other. So you would basically just have A over 5 in this when you multiply those. All right. And so you guys forgive me for my poor mouse writing skills. All right, let's erase this and we're going to move on down just a little bit. Perfect. Okay, this is possibly one of the most important rules in business math. We'll use this over and over for the whole rest of the class. Whatever you do to one side of the equation, you have to do to the other. We're really looking for balance when we're doing this. So what you do to one side, you've got to do to the other. So that's learning unit one. We're going to move ahead. We're going to go on into learning objective or learning unit number two. And this is about how do we solve for those equations now? So how do we solve for those unknowns? So there's what's called an opposite process rule. And this is, if you're in the physical textbook, we're on page 124. If you are in the ebook, we're on page 54. So the opposite process rule really just says if an equation indicates a process like addition, if we're adding, to solve for the unknown, you've got to use the opposite. And so we need to think about, okay, what are the opposites? Well, adding, the opposite is subtraction, right? And then if we are going to be multiplying, the opposite would be dividing. And that also goes vice versa. So if we're dividing, the opposite would be multiplying. And if we're subtracting, the opposite would be addition. So these are just some kind of key points that you'll need as we go along. All right. The next piece talks about the equation equality rule, and we'll actually look at this in an example here in just a moment. So let's go down to this first drill problem. This is a pretty good one just to practice on. So our example here is A plus 8 equals 58. And we're told that Dick's age, which is A, plus 8 years equals 58. Well, in your head, you can probably already figure out what his current age is, right? So his age plus 8 is 58. Okay, then he's 50 years old. This works really great with simple problems. But when we get to a little bit more complex problems, we're going to need to learn this formula or this step. So what the book calls it is the mechanical steps. I call it the long way. So what we do is we write out the equation. Age plus 8 equals 58. So Dick's age, A, plus 8 equals 58. Okay, we've got the equation. Now we're looking to solve for A. So we want to know what is Dick's age. So to do that, we've got a plus sign. So we've got A plus 8. So the opposite of adding is, you got it, subtracting. So on this side, we're going to subtract 8. And so 8 minus 8 gives us 0. So there's nothing there left after we do that. And we just bring our A down. So that's what's left over on the left side of this equation. Then over here, remember what you do to one side, you have to do to the other. So when we subtract 8 from 58, we get 50. Now, what that tells us is Dick's current age is 50 years old. You've just solved an equation. So pat yourself on the back. Good job. Now, you can always check your equations. You can check your work with all of the problems we do in this class, and it shows you how to do this here. So we said A equals 50. In our original equation, A plus 8 is 58. All right. And we said A equals 50. So 50 plus 8, hey, we got it. That equals 58. So in these first problems, you can always check your work very, very easily. In the future, it might take a few more steps to check your work, but you can still do it. Now, what I would encourage you all as you're going through this class is certainly to get a notebook and walk yourself through these practice problems. I know that sounds so weird, right? Let's read a math textbook and let's write down the problems and talk ourselves through it. But this is how you're going to learn this information is by literally practicing it. The repetition, they say, There's an old quote that says, repetition is the mother of all skill. So the more you repeat something, the better you become at that skill. Okay, now we're going to go down just a little bit more. We're going to look at adding and excuse me, adding the same number, and then we're look at dividing and multiplying. So you can get a little bit of a view over each of the different ways that we do these, the opposites. So drill situation number two is B minus 50 equals 80. And here's the word problem part, okay? Sometimes the word problem really freaks people out. They go to like freak out level 12 when they see a word problem. But I'm going to teach you in this class how you take those sentences and you just kind of break them down to their parts, really. Okay, so this says some number, which we are calling B, less 50, which just means minus 50, is equal to 80. So do you see how we did that? Some number B, so okay, this number B, we're calling it B. We don't know what the number is, but when you take that number and you subtract 50 from it, you're going to get 80. Now, I bet your brain is already working this out because you know that what we do to one side, we've got to do to the other, right? So when we look at, okay, on the left side of this equation, we have the minus 50. We're always trying to get the letter by itself. So we want to have the letter on either the left side or the right side of the equal sign. Doesn't matter where it goes, it just needs to be by itself. So this is pretty easy based on what we've already learned. We've got a minus 50 here, so that means we've got to do plus 50, right? And then what do we have to do on the other side of the equal sign? You got it. What you do to one side, you have to do to the other side. So now we know on the left side of this one, we've got our B all by itself. So we nailed it on that. Now we've got to add 80 plus 50, and that's going to be 130. Now, I can look over here, right, at my mechanical steps and I can see right on, I did this one the right way. This is how I would actually encourage you to go through these chapters in this way. Yes, I know you can see the answer plain as day right here, but if you kind of start training your brain to do it in this manner, like write down the problem, work it out, take a look at it, you will build a skill that will help you as you go out or go on through the rest of this class. Okay, and then it tells us, hey, you know what? You can check that out. We found out that B equals 130. So we basically just take our original equation, B minus 50 equals 80. Okay, now our B was 130. 130 minus 50. And you can put that in your calculator, or maybe you can do it in your head. But we want to check and see, is that true or false? It's true. So that means our answer is correct. So keep in mind, like I said, you can always check your answers. All right, I'm going to get this erased, and then we're going to move down the screen just a bit. We'll take a look at dividing. And I bet you can already do this one on your own. So maybe you want to pause this video and just try it. Just see what you come up with. All right, so if you're back with us, here we go. Our example is 7G, which we know that means we've got 7 G's. 7 times G equals 35. And the way the words are is some number that we don't know, we're going to call it G, times 7 equals 35. So what this really is saying is 7 times G equals 35. That's kind of the longhand way to write this. But in business math and algebra, we take out that X or the multiplication sign and we just put it right beside the letter. So when the letter is right beside the number, that means we're multiplying. Okay, so I'm going to kind of erase my scratchy writing here so that we can work out this problem. All right, so we've got 7G equals 35. Now we all remember what we do to one side, we've got to do to the other. And we want to get the letter by itself or the variable by itself. And we know we need to do the opposite mathematical function. So remember, if we're adding, we're going to subtract. If we're multiplying, we're going to divide. and vice versa. So my G is on the left side of this equation. And to get rid of it, what I need to do, okay, it's multiplying. So what's the opposite of multiply? You got it. It's dividing. So when I have my sevens and my sevens here, they cross each other out. And so I've got G by itself. I'm out of room. So we're going to just go over here. Okay, I've got my G by itself. And then 35 divided by 7 is 5. So the way I've worked out this equation, if I've done it correctly, my G is going to equal 5. Well, we know how to check that, right? We take our original equation up here, and we've got 7 times, I'll put a little dot here, 5 equals 35. And that is true, right? 7 times 5 is 35, and we're good to go with that. So we've solved that equation. So we've had an opportunity to look at adding, subtracting, and dividing. Now we're going to take a look at multiplying. So let's move down our screen just a little bit. And here is our example. Now, lots of times students will literally freak out when they see fractions. And I want to encourage you, like, take a deep breath. Fractions can be your friends. They're not going to be that hard in this class, I promise. We're not going to do those really hard ones like you might have seen back in high school or middle school. The fractions we use in here are going to be fairly simple. Okay, so let's take a look at this drill situation number 4. Our word problem this time says some number, which we're going to call V, like Victor. So the number divided by 5 equals 70. And so we've got an example of that. V divided by 5 equals 70. All right. So we want to remember, okay, I've got to get my letter by itself. And to do that, whatever I do to one side, I've got to do to the other. And to do that, I have to do the opposite. Okay. So this is V divided by 5. So to get that V by itself, we're dividing here, so we've got to multiply. So I'm going to rewrite this so I have a little bit more room. Okay. And I'm going to put little parentheses around here because I'm going to multiply. And on this side, I'll do the same thing. Okay. So your 5 here and your 5 underneath your fraction are going to cancel out. So that's going to give you V on the left side. So we've got our letter by itself. And then 70 times 5, you may have to put that in your calculator, you may not. But that's going to give us 350. And so we can check that by saying, oops, let me erase that V. I didn't mean to write that. We said that V is 350. So in our original equation right here, we're going to say 350, which is where our V was, divided by 5 equals 70. And so on your calculator, you can just type in 350 divided by 5 and hit enter or equals, and you're going to see that that equals 70. And there you go. You've solved your equations. All right, so that's just walking us through how do we get that variable or that letter by itself on one side of the equation. And we also need to remember that we use the opposite mathematical function to move it. So if we're adding, we're subtracting. If we're multiplying, we're dividing, and vice versa. Okay, let's look at drill situation number 5. This is where it gets a little bit more complex. And so this is using multiple processes. And so our little rule here in the purple and tan box says, when you're solving for an unknown or a variable that involves more than one process, you'll do the addition and subtraction before you do the multiplication and division. And so here's our example. We've got h over 4 plus 2 equals 5. Here's the word problem for that. When we divide an unknown number, we're going to call it h in this problem. So when we divide an unknown by 4 and we add the result to 2, the answer is 5. So take a minute and try to get that picture in your head. So we're dividing some number by 4 and we're adding 2 to whatever that is, then we're going to get 5. And so then it shows us over here our mechanical steps. And remember, it's a good idea to write this out in your notebook. So if I've got h over 4 plus 2 equals 5. All right. So my multiple process rule tells me do the addition and subtraction first. And so to get rid of this 2 on this side, it's added. So I need to subtract it. And then I'm going to do 5. Oops, let me erase that real quick. I wrote the wrong thing, y'all. Okay. So we're going to minus 2 there, and we're going to minus 2 here. And so what that's going to give us, this is just going to come down. So h over 4. The minus 2 and the plus 2 cancel each other out. So we've got an equal sign. And then we've got a 5 and a negative 2. So 5 minus 2 is going to give us 3. So now this looks like what we've done before. We're kind of in familiar territory. So we've got h over 4 equals 3. And so we know, okay, I've got to get my letter by itself. And to do that, I need to do the opposite mathematical function. So h divided by 4, I'm going to multiply by 4 both sides to get that 4 out of there. So I'll just do my little multiplications. We'll put a 4 here. I'm going to put a tiny 4 here because I ran out of room. And the two 4s are going to cancel each other out. So in this equation, h is now by itself equals 3 times 4, which is 12. Now, here's the good news. You can still double check this, right? So you know what your h is. We're going to go back to our original problem, h over 4 plus, let me make that a better h there. That's kind of a bad h. Okay, plus 2 equals 5. Now, I know that my h is a 12. So this is going to be 12 over 4 plus 2 equals 5. So 12 divided by 4, you can put that in the calculator, or you may know it in your head, is going to be 3 plus 2 equals 5. Hey, check it out. That is true. So we are good to go on that. We've solved that equation. And that one was a little more complex than the ones that we've done before. All right, let me just erase this up. Keep erasing. All right. And we're going to go down just a little bit in our textbook. And we're going to look at drill situation number 6, which is using parentheses to solve for the unknown. So we've got a parentheses rule. And if you're putting notes in your notebook, sometimes it's a good idea to put these little rules in your notebook so that you have them right there so you don't have to keep looking back through your book. So this is a good idea if you're taking notes. Jot down the rule or jot it down in your own words, for example. Here's what the parentheses rule says. When equations contain parentheses, which indicates you're grouping things together, you want to solve for the unknown by first multiplying each item inside the parentheses by the number or the letter just outside of the parentheses. Then you continue to solve for the unknown using that opposite mathematical process that you already know from before. Then you do the addition and subtraction first, then the multiplications and division. Okay, that sounds super complicated. Let's take a look at it together. So we're given an example here. Let me change the color of my pen. Okay, so our example is 5 parentheses p minus 4 equals 20. And so the words for this are, there's an unknown here. We're going to call it p. So p less or minus 4 multiplied by 5 equals 20. So I would write that down as p less 4, and then all of that multiplied by 5 equals 20. Okay, so I've taken that sentence and I've broken it down into numbers and letters. So I now have an unknown p that I can solve for. And so what we're going to do is we're basically going to take this 5 and we're going to spread it out into the inside of this equation by multiplying, because the 5 is right beside the parentheses. That means we're going to multiply. So when I take 5 times p, that gives me 5p, oops, minus, going to be, let me do an eraser. So I don't think that's a plus. There we go. Okay. I'm going to keep my minus sign. 5 times 4 is going to be 20. And then I don't do anything to this right side because there's no number to do anything with. There's no letters, there's no variables. It's just 20 by itself. Now we've got an equation that looks pretty familiar. We've already done some like this. So I know I've got to get my letter by itself, and I've got to, what I do on one side of the equation, I've got to do on the other. And I use the opposite mathematical function to separate the letters from the numbers. Okay, so what we're going to do first is we're going to take, what we're going to do first is we're going to get rid of that 20. So remember in our parentheses rule, it says do your addition and subtraction first. So I'm just basically going to say the opposite of minus 20, right, is going to be plus 20. And I'm going to add 20 to this side. Oops, that's a 0. We'll put a line there. This 5p just comes down. I didn't do anything to that, so it's just going to drop down here. Now the minus 20 plus 20 gives us 0. And then the 20 plus 20 is going to give us 40. Okay. Now we're over here with, so, oops, let me put that back where you can see it. Okay. Now we are with an equation that's pretty simple to solve. We've got 5p equals 40. Well, we know that 5 next to the p means it's multiplication. So to get rid of that, to make the p go by itself, I'm going to divide both sides by 5. And what that does is it cancels out here. So I've got p equals 8. And then, as we remember, we can check this. And so they've got our example here of how we check it. So our original equation was 5 times p minus 4 equals 20. And what they did in our book is they just substituted, they just substituted 8 for our p, and then they worked that problem. So 8 minus 4 is 4, and then we carry that 5 down. And then 5 times 4 is 20, and 20 equals 20. So it's all true. All right. So far, we've looked at 6 different examples or 6 different drills of how we can solve for the unknown. Let's scroll down just a little bit. And next, we're going to talk about combining like unknowns. And this one is, you're not going to be surprised at all. You're probably going to be like, hey, this is kind of getting a little bit easier. So to solve equations with like unknowns, so that could be you have 2 or 3 different A's or 2 or 3 different B's or any letter actually. You're going to first combine those unknowns, and then you're going to solve with the opposite process used in the equations. So here is our first example. 4a plus a equals 20. Well, we've got 4 A's, and then we add one more A. That's pretty easy, right? We've got 5 A's now. And then the 20 just stays the same. Check it out. You already know how to do this one, right? We want our letters or our variables by themselves. And to do that, we have to use the opposite mathematical formula. And what we do to one side, we have to do to the other. So we are going to divide 5a by 5. We're going to divide 20 by 5. So that gives us a is going to be equal to 4. And we can definitely go back and check that by putting that 4 in our original equation. And they've got the example of it here. 4 times 4 plus 4 equals 20. And the way we work that is 4 times 4 is 16 plus 4 equals 20. And that is true. So we've done it. We did one more equation. All right, let's get this erased up and we'll take a look at what is going to be next. All right, so we are going to move on to page 55 in the textbook. And this is, let me just put my annotations back up here because I have some stray marks that need to be erased. Okay. So on page 55 of your e-textbook, And then this will be, let me just see what page this is on in your physical book. It's going to be page 127 in your physical book. You've got some practices. I highly recommend that you do these in a notebook and check it out. You've got the answers down below, but don't try not to look at those. Maybe put a paper or an index card over that bottom half of the page, or just don't scroll down. But take a minute in your notebook and look at, number 1A. 9 less than one half of a number is 14. So here's how I would do that one. Okay, 9 less than one half of a number. So I know we're going to be subtracting 9 from somewhere. So 9 less than one half of a number, and you can make the number anything unless it tells you otherwise. So in our instructions, it says use Q as the variable. So, okay, I'm going to use Q as my number, and then is equals and then 14. So I always double check and I say, does this match what the words say? So 9 less, got that, than one half of a number, got that, is 14. Okay, so I'm pretty confident in my answer. I can then just scroll down to the bottom and see, does my calculation or my equation that I wrote match the one that's in the book? And it does. Let me see if I can scoot that screen a little bit so it's not so scribbly for you. There we go. So you can see that the 1 half Q minus 9 equals 14. My arrow's going the wrong way there. So it's actually going to be this one. So you can check yourself. I would definitely recommend if you have not done these problems yet, or these drills, go ahead and try those out. This is going to help you a lot in future chapters where we're working out our equations. All right, that's Learning Unit 5.1. Thanks for hanging with me on this video. Like I said, next week we'll have a different camera, and let me just get back on video here. All right. Next week, we'll have a different camera. It'll be an overhead, and I can just write down on paper and you'll be able to see it. But hopefully, that kind of helped a little bit with that first learning unit in 5.1. I'll be doing 5.2 here in just a bit. And if you have any questions, don't hesitate. You can send me a message in Blackboard, or if you want to send me an email, it's cwooten@roguecc.edu. All right, folks. Have a good day, and I'll see you soon.